Okay, today I'm going to start on a review on 2020 TYS paper 2 and 3, some of the questions, right? So I've selected some questions that are a bit tougher. Okay, let's start with paper 2, question 2. If you have the question or if you want to refer to your hard copy, that will be good. Okay, this question is on gravitational field. It's 8-mark questions, paper 2. Okay, 2A, they ask you to define what is meant by gravitational potential at a point. So the gravitational potential at a point is the work done per unit mass by an external agent in bringing a point mass from infinity to the point. So there are certain key words that are important. For example, work done per unit mass. And of course, we also must understand the difference between an external agent and a gravitational force. So this is the F external, just like in the notes. We also have something called a gravitational force. Okay, this is to bring a point mass from infinity to the point. So remember, this is always from very far away to the point. Okay, what are some of the comments on this question? Most of the definitions actually were quite stated accurately. Some of them actually omitted the mention of work done per unit mass, or some of them actually mixed up without stating from infinity to the point. Okay, how about there are also other points. For example, you can talk about without a change in KE, there's actually no acceleration. It's actually moving at a constant velocity. So for part B, there's some calculations required. So this is on Earth of radius 6,400 km. It has a mass of so much. Okay, now you have a GPS and the mass is actually in an orbit of a certain distance away uh, from the center of the Earth. Okay, so have to take note, right? This is actually away from the center of the Earth. So if you were to draw the diagram, so you have to be careful. So actually I'm a certain distance away. The satellite is probably here. Okay, so you're away, away from a distance away from the center of the Earth, not from the surface of the Earth. So the satellite is actually launched from the Earth's surface. So you launch a satellite outwards. Okay, calculate the change in GPE for this satellite. So again, what are the key things that you have to know? Firstly, of course, your formula for GPE, right? Minus GMLR. And of course, on top of that, you have other formulas such as KE and your total energy. So there are a few formulas that you must know how to derive, right? Total energy, kinetic energy, right? So for instance, in this case, now they're asking for the change in GPE. So I just use minus GMM over R. Of course, you have to be careful with what is your M, big M and small m. Of course, now you can use M1, M2, but just make sure you know what are the masses involved. So the change in GPE, I take the final GPE. Okay, always take the final minus the initial GPE. So the GPE at the furthest distance away minus the GPE from the launch. So minus GMM 1 over R and minus 1 over big R. So just be careful about the distance. Big G gravitational constant value, if you're not sure, let's take from your data booklet, minus 6.67 times 10 to the power minus 11. Mass of Earth is actually given 6 times 10 to the power 24. And then the other mass for your GPS satellite is actually 1,600 kg. And of course, with your distance involved, the two distance. Okay, so always have a good habit. Just check, make sure this is in, for example, this is in km and this is in meters. Just be careful about the units, right? Take care of the units. Okay, so if it's km, just make sure you convert to meters. Make sure you standardize the units. Okay, once you do that, you subtract off, you do the calculation, you should get a value of 7.6 times 10 to the power of 10 joules. Right, so because it's moving further and further away, so by right, your change, this change should be a positive change, right? It should be an increase, right? So that's why you expect a positive increase. A change will be an increase because it's launched further and further away. It's going further away. What are some issues with these questions, right? Of course, like I mentioned, the radius often is a problem, right? So be careful about the phrasing. Just make sure if it's center, from the center of the earth, or is it from the surface of the earth? Okay, the second issue is about the km, the kilometers converting to meters. I think these are common pitfalls, so just be careful about it. This question on energy, so make sure you use the correct formula, your GPE, your KE, your total energy, right? Rather than using a force, which is GMM over R square, right? So just be careful about the formula used. This is gravitational force, GMM R square. Okay. Okay, C1, you have this satellite that orbits a planet of mass m. The mass is assumed to be a point mass. You're expected to show this formula for kinetic energy, GMM over 2R. So again, this formula by right, you should have known this on top, or like I mentioned, your GP formula as well as your total energy formula. Okay, so this question asks you to show, that means it's a explanation with some workings required, right? So as of now, by now, you should know that gravitational force is provided by centripetal force. It's something that you have to write. Okay, make sure you write your FG, and your FC. Okay, you can't just write FC and FG, right? So make sure you spell something. Your gravitational force provides the centripetal force. Okay, your formula for centripetal force, mv squared r. Your gravitational force, GMM over R square. So if I cancel the R, I will get GMM over R. So my KE is half MB square. Okay, and my V square is half MB square is here. So I plug this formula in. I should get GMM over 2R. Okay, which is a formula that you should have memorized by now. Okay, so make sure you know the formula for KE, GPE, and total energy. Of course, this question is a show. Just remember the expectation of the question, right? It's a show question. Make sure you provide step-by-step presentation of the algebra. Start with a statement. You need a statement. So make sure you write a statement first. Okay, then of course, of you, after having written the statement of Fg centripetal force provided by gravitational force, make sure follow, most of them can actually do the Ke expression, right? Just take note of this. Show questions are important to include all steps. All right, just remember this. You must include all the intermediate steps, right? Because it's a show. So if you see this question, just know the expectation of question. Just make sure you include all the intermediate steps. You cannot skip steps, and then therefore, for example, if the decimal is a numerical value, you skip step and then show the value. You're expected to show the raw value before you round off. Okay, C2, they ask you to use the information in B and the expression in C1 to calculate the KE of the GPS. Okay, it's only a 1 mark question, so by right, it shouldn't be very tedious. Your KE is GMM over 2R. So gravitational constant is 6.67 times 10 to the power minus 11. Your two masses are given, and your times your divide by your 2 times radius. So with that, you'll get a certain value, and of course, you round off accordingly, right? To 1.2 times 10 to the power 10 joules. Okay, okay, this question asks you to use information in B and C1 expression. So make sure you use what you are expected, what you are told to do so. Use the expression in C1 to calculate the KE. C3. Okay, the part 3, of course, is the harder part. A student want to calculate the change in KE launch from Earth to its orbit. So this student actually used the formula in C part 1, right? So you are asked to explain whether the student method is correct or not. So your formula of GMM over 2R. Okay, so the question here is the satellite was launched from the Earth to the orbit, right? So it was launched from Earth to orbit, to a certain orbit. Okay, and with reference to GMM over 2R, is it correct or not? Okay, this answer will be incorrect because your GMM over 2R, like I mentioned, this question is actually of a satellite launch from Earth to orbit. So it's not applicable for a body resting, because when there is a gravitational force, as what you have done just now, your Fg and your Fc, that's how you obtain your equation of GMM over 2R. So fundamentally, if you get this Ke formula, it's because your gravitational force provides a centripetal force. But on top of that, now we have a normal contact force. So because of this, your derivation of this formula does not hold, right? So this is only true for where the only force providing the centripetal force is your gravitational force, your Fg equal to Fc. Okay, so the Ke now it will be different from using GMM over 2R, but of course the final Ke no problem because the satellite is actually in orbit. But because this satellite is actually launched from the Earth, so it's actually not in orbit. So there's Fc equal Fg does not really hold in this case, because of your normal contact force. Okay, so additionally, there's also an issue of this satellite. There are questions on whether the satellite can be on the equatorial plane or not. So all this will affect because it goes with the direction of the rotation of the Earth, whether it go against or go in the direction. So you affect the Ke, right? So that's why the answer, the student method of deriving a change in Ke is incorrect. Okay, a very tough questions, which rightfully been pointed out, right? Satellite, many candidates actually claim that the satellite was not in orbit or undergoing circular motion. Okay, a lot of them say that the GPE chain, GPE should also be included, but the question actually asks for using the expression in C1. So there's actually there's no need to talk about GPE changes, right? Because the question already asks for expression in C1. Okay, so just focus on KE change. You should be able to derive this. Just bear in mind how you derive GML2R is actually Fg equal to Fc. Okay, and think of what other forces there are for this object that's actually launched from Earth to orbit. Then you realize the KE cannot be found using this formula. Okay, that's all for question 2. Now go on now to question 4. Okay, question 4, this question is actually on superposition. Okay, wave and superposition. So for A, they ask you to explain what is meant by the term diffraction. So diffraction is the spreading of the wave onto the geometrical shadows regions when they pass through an opening or around an aperture, right? So there are certain keywords that need to be there. For example, spreading, don't mix up with bending. So good to use the word spreading. Okay, comments on this. Many candidates can describe the wave spreading and passing through a slit, aperture, a gap, or obstacle. Of course, some of them refer to bending or wave, or they did not realize that the wave passed through a single slit, edge, obstacle, gap. Okay, so other comments on this. Of course, the other things that you must know, for example, how to get observable diffraction, right? When the wavelength of the wave is about the comparable wave order of magnitude as the dimension of the aperture of the gap size. Okay, part B asks you to state two conditions required for two source interference fringes to be observed, your Young double slit. So here we must know conditions, right? In the notes, we have a few conditions. Here they only ask to state two conditions, right? So take note also that this is actually a state question. So the number of lines is also given as such. So please do not overwrite. Make sure you know what is expected of you. To write for conditions for a Young double slit interference, right? So for this experiment, you should know something like lambda d over A, right? That will equate to your fringe separation. Okay, so state question, the two wave must be of the same nature, same type, and obviously they must overlap, they must meet so that they can interfere. Or you can talk about them being must be coherent, having a constant phase difference. Right? Of course, these are not the only conditions that are there. You also can talk about they having the wave must have equal about the same amplitude so that they can cancel to give me a complete disruptive interference, or they add up to give me a very good complete constructive interference. Okay, how about monochromatic wave? Same color, same frequency, same wavelength. Right? So these are things that you can mention also, the conditions necessary. Polarization, you must make sure that the wave that are emitted, they are either polarized or unpolarized in the same plane. So this is for transverse wave. Of course, we know that longitudinal wave cannot be polarized at all. Okay, most answers were good. Some errors arose from comparing slit wave with the wavelength or distance approximation, small slit separation, and far distance. Okay, polarization, of course, you need to talk about plane, whether they must be polarized or unpolarized. Coherence is having a constant phase difference, right? Some of them mix up, they thought they have the same frequency or wavelength as separate requirements. So this is something, conditions that I think we can do our part. Just make sure you know a few conditions for Young double slit for two source interference to be observed. Okay, the next part, you're actually given a graph. So it's a X and a D graph. So you use a laser, right? The laser light is actually normal to the plane, right? So using a laser and you produce some fringes on the screen. Separation is given as 0.12 mm. So just take note, this is mm. Okay, you are expected to find your answer wavelength in terms of meters. Okay, so just do a quick glance, right? This X. Yeah, your fringe separation is in terms of 10 to the power minus 3 meters. Your distance, D, is in terms of meter. It's actually a straight line. So things to ask yourself is, why is this graph a straight line? How can I get this graph? How can I plot the X against D graph? Okay, so firstly, like I mentioned just now, Young double slit. So make sure you know the formula. X equal to lambda D over A. Make sure you know what are the different symbols. What do they represent? Your X, for example, your fringe width. Your D is the separation apart. Your A is a slit separation, right? So if I want to get this graph, okay, how can I get the gradient of this graph? So by plotting X against D, you will know that the gradient is lambda over A, your wavelength divided by your A slit separation. So if I want to find X, I want to find lambda. So make sure I can find the gradient. I already have the slit separation with given, right? So this value slit separation is given. So I just need to find the gradient of the graph. Then from there, I can find the lambda, the wavelength. So the first step you need to do is go to your graph, find the gradient of the graph. So this is step one, right? You need to find the gradient. Okay, so make sure your change in y over change in x. Take note of all the orders, 10 to the power minus 3. Do not forget about this. So you work out the gradient is of this value. Okay, then that is lambda over a equal to the gradient value. So how to find lambda? I use the gradient times the slit separation. So I will get a value of 5.3 times 10 to the power minus 7. So for a question that involve a graph, or rather a graph is given to you and you are expected to calculate some unknown from the graph, make sure the first thing your thinking process should be how to linearize a graph so that you can find whatever you need to find. Okay, so in this case, I need to linearize this graph equation of x equal to lambda d over a. So how to manipulate this equation so that I can get the gradient value. Of course, the other way to think of this is sometimes for graphical approach, you can think of the area. If you can't find anything from the gradient, try to see whether there's any significance of the area. Of course, in this case, there's nothing much. Okay, so the next thing to take note is, of course, when you find gradient, make sure the points that you use, the gradient coordinates that you use, right? The 2 points must be far away, right? Don't use points that are close. Too close to each other. Okay, most answers were correct. Power of 10, so this is the oftenly a careless mistake, right? On the y-axis, right? Some of course cannot linearize the equation. They fail to see that the gradient is lambda over a. So a lot of them just put them as wavelength. Okay, part 2, you are expected to find the ratio of intensity. Right, so a filter is used so that the amplitude of the light from one slit is half. So the amplitude has dropped by half. Okay, one of them dropped by half and the other one stays the same. So you're asked to find the intensity, right? So this is the intensity ratio. So the thinking process comes to you should be how to find intensity and how to correlate intensity and amplitude, a square, right? So think of I proportional to a square. So if I can find the amplitude, I can find the intensity ratio. Right, so of course the central is always a bright fringe due to complete constructive interference. Then you have a dark fringe, which is due to your destructive interference. Okay, so the two way that comes in at a bright fringe, the resultant amplitude is A1 plus A2. Right, so this is due to principle of superposition. We sum up the amplitude, right? Principle of superposition. Okay, you always sum up the amplitude, right? Remember, please do not sum up the intensity, right? Please do not sum up the intensity, you sum the amplitude. How about the dark fringe? So the resultant amplitude of dark fringe, you take A1 minus A2 so that I can get a destructive interference. So if now one of them is actually 2A, but because of the halving of the amplitude, the other amplitude now becomes A. So at the bright fringe, I have 2A plus A. I will get a resultant amplitude of 3A. At the dark fringe, my resultant amplitude is 2A minus A. I'll get a resultant amplitude of A. So since your intensity is proportional to the square, right? Square of the amplitude. So I can use this relationship to find my intensity ratio. So I put Ka square, Ka bright square divided by K amplitude dark square, right? So remember the A here refers to the resultant, right? It's a resultant amplitude due to principle of superposition. So it's 3A divided by A square. So A and A will cancel. So I'm left with 3 square, which is 9. So I'll get a 9. So the ratio is 9, right? Oh, this is a question on ratio. So please remember ratio, we don't live in fraction. For example, you have a number such as, let's say if other numbers such as 1 over 9, please remember, do not put in ratio. Do not put in a fraction. Convert them to numerical values, right? 1 divided by 9. So in this case, I put as 9.0. Okay, many candidates were able to answer this question correctly. Some of them, however, were unable to determine the amplitude of the central and dark fringes due to the principle of superposition. Right, some can state the relationship, right, between the intensity and amplitude. but you fail to apply it correctly. So remember, this is important, I proportional to A square. Okay, and also remember, like I mentioned just now, please do not sum up the intensity, individual intensity. You always sum the individual amplitude to find the resultant amplitude. Then from there, if you want to find the resultant intensity, you work from I proportional to A square. Okay, so this is the end of question 4. Okay, I'll move on to question 7 on quantum physics. So quantum physics, first part, they tell 7A, they ask you to explain what is meant by a photon. And it's a 2-mark question. It's a explain. So you're expected to write down what is meant by a photon. So a photon is a quantum of electromagnetic radiation energy. So remember this, right? It's a packet, right? In layman term, we call it a packet, right? A quantum of EM radiation energy. Of course, you also have to write down E equal to HF. So remember to write E equal HF, where H is your Planck constant, your F is your frequency. So remember to define any symbols that you use in your equation. For example, E equal HF, right? Make sure you write down what is H, what is F. Okay, these are generally quite easy questions. Some explanations, however, make no mention of EM spectrum, right? So do remember the word electromagnetic radiation energy is important. EM spectrum is important, or there must be reference to energy, E equal HF. Okay, part B, I'll tell you about a beam of light that passed through a cloud of gas. Then thereafter, you see a spectrum, and there's actually some dark lines. So they ask you why are there dark lines, right? How come the dark lines are formed? So again, if you recall, there are dark lines. There are also the other one, which is a bright lines. So this is actually a case of absorption, right? Spectrum versus the other case of emission spectrum. Okay, so in your mind, you must make sure you know how to explain the formation of emission spectrum, formation of absorption spectrum, and how they look like. Okay, so in this gas, most of them are actually the ground state, so at the lower energy state. So when you excite them, when you shine some white light onto the gas, so the atoms actually absorb the photons, right? So imagine I draw just a few, just draw 3 levels. So the electrons, right, the atoms will actually absorb, the photon comes in, the atoms will actually to absorb the photons, the atoms will move up, right, equal to the electron energy level present in the gas atom. So this amount of energy absorbed is equal to the gap, right, causing the electrons to be excited. So the moment the electron excited, they start to get agitated, they start to move up, right? The excited atoms, electrons, then de-excite. So if they are excited, they will never stay excited forever. Within a short period of time, they will quickly de-excite, right? So if they de-excite, they will move down, right? So once they de-excite, they'll emit photons. They'll emit photons, right, that were previously absorbed. So this is the idea of quantization of energy. So I make sure that the atoms, they get excited, the electrons move up, but they must absorb a packet, a quantum of energy that is equal to the gap size, right? The energy gap between them. So the photons, in this case, because the electrons de-excite, the photons emitted are of certain, right? Certain energy, right? Certain energy, they will have certain frequency because of E equal HF. So if the energy is discrete, the frequency is also discrete. So a particular frequency of a photon will be emitted. So you only see certain colors, right? As the photons are emitted, they come out in all directions randomly, right? So there's actually a decrease in the number of these frequencies that were absorbed and re-emitted, right? So that's why there are dark lines, right? There are dark lines on a colored background. Well, this question did not ask for the appearance of the absorption spectrum. Right, so these are actually dark lines on a colored background, right? Colored spectrum. Okay, being heavy on theoretical recall background information, I think not many candidates were able to provide a good, complete, comprehensive explanation of absorption spectrum, right? So this whole idea of electrons get excited, they move up, then thereafter they get de-excited, they move down the energy level, and they emit photons randomly. Right, some response were only mentioning that the atoms, the gases, only absorb light at a particular specific frequencies. Right, so some candidates focus on de-exciting to emit photons. Right, and noting that these photons are emitted in random directions. So also take note that once the electrons are emitted, right, these photons actually are emitted randomly, right? So they account for the darkness of the lines. Hydrogen atom, part C. So I have a electron energy level for hydrogen atom, right? There are different levels, N2, N3, N4, N5, and N6. There's actually an energy in EV. Take note of this. This is electron volt. So N is called the energy level corresponding to here. So as the N increases, the E will change according to this formula. Part 1 is quite straightforward, right? They ask you to calculate the energy in terms of electron volts. Okay, make sure you know electron volts, make sure you know what it stands for, and how to convert electron volts to joules. Okay, you are expected to find the electron energy for n equal to 2, right? So n equal to 2, n2. So what do? I use the formula minus 13.6 divide by 2 square. So I'll get minus 3.40 EV. The question only asks for energy in terms of EV. So for this part, there's no need to convert to joules. Just leave your answer in terms of minus 3.40 EV. Okay, part 2, they ask you now to find the wavelength absorbed when the electron in N2. So electron is here. The electron will get excited to here. Right? So you get excited to N3. So what happens when the electron get excited? Okay, what is the amount of energy absorbed? Then that corresponds to the wavelength, because you know for a photon, the energy by a photon is equal to hf, which is hco lambda. Okay, so from N2 to N3, firstly, I use the formula divide minus 13.6 divided by N square. So 3 square, then you subtract away minus 13.6 divided by 2 square. So you'll get an answer for the absorption of the photon in terms of EV. Make sure you convert the energy in EV to joules, right? By multiplying 1.6 times 10 to the power minus 19 joules. Okay, so this is the conversion, right? So make sure you take note of the conversion. 1 EV equal to 1.6 times 10 to the power minus 19 joules. Okay, which is similar to that of an electron charge. Okay, if you have trouble just remember that this is actually an electron charge. So using the formula for energy equal HF, F is CO lambda and C is speed of light. And speed of light has a certain value of 3 times 10 to the power 8. So I can find the lambda. Planck constant is 6.63 times 10 to the power minus 34. So this value you can get from the data and formula page. Right, speed of light, same thing, 3 times 10 to the power 8, you can get from the formula page, divided by energy in terms of joules. So remember to convert to joules, otherwise you'll be stuck with the answer of EV, right? EV, right, which is wrong. Okay, from there you can get your answer for wavelength, 6.6 times 10 to the power minus 7 meters. Okay, if you know your spectrum well enough, then you roughly can predict that you can also check your answer for the lambda that it should not be obviously wrong, right? The order of magnitude should be nanometers, few hundred nanometers. Then, okay, answers were correct. Some candidates provide the correct expression for wavelength. Majority of them were able to do a E equal HF equal to HCl lambda. Okay, like I mentioned, the energy conversion from EV to joules. So please take care of this. You must know how to convert energy difference from electron volts to joules and vice versa. Okay, part 3, they ask you to explain why the energy of each energy level is negative. So this is only a 1-mark question, right? So we can talk about a free electron, unbounded electron. The energy is defined as 0. This by sign convention, right? So the negative energy is something like the concept of work done, right? Work done by external agent, work done by gravitational force. So we can mention that this guy, energy requires the electron in this atom require energy to be excited and to be escaped from the atom. Okay, so how is this a concept of work done? Okay, we can do this. You can write your energy as negative work done by external agent. Okay, by external agent in bringing electron from infinity to that point. So let's say this is infinity. I'm trying to bring the electron to the point. This is my point. So this guy is an electron. My external force will be this way. Okay, so my displacement will be this way. So if you use your work done, there's actually a negative work done by external agent because the external force point in the opposite direction to the displacement. So there's a negative work done by external agent to bring the electron from infinity to that point, right? From infinity to the point, which is similar to what we do for gravitational field, right? So this is the idea of why energy is negative. Okay, that is of course these are the common feedbacks, comments on this question. Energy is negative due to the electron negative charge, right? Some of them mentioned by convention, potential energy is 0 at infinity, which is insufficient. Okay, so that's all for that question. Now we go on to the question on data, right? Data question for 2020, which is question 8. This question involve concepts integrated across different topics, kinematics, dynamics, your forces, your Newtonian, and also your thermophysics, right? So they give you a formula, F1 formula. So they talk about vehicles, right? They tell you about acceleration. If you read the passage, maximum speed is 585 km per hour. Straight line distance. They also give you a graph, a coefficient of friction against temperature. So they give you a formula F equal mu W. Okay, there's a diagram on how the tire looks like. Right? There's some gaps in between the tire and the surface, which you are asked later on. So when it's hot, we all know that it's very hot during F1 race, increase the surface contact area. Okay, so go around tight corner, they will decelerate, and the corner is this. Acceleration is up to 4g. Typical mass of F1 car is about 750 kg. Then they also mention about distribution of weight, right, between the front and the weight back. So this is called a weight transfer. So when the car accelerates, there's actually a transfer of weight from the front to the back. Okay. They also use brake pads, right? So there are each of them, there's a set for each of the 4 wheels. So altogether there are 4 brakes. Each set has a mass of 1.2. There are about thousands of holes, right? So later on they'll ask you what's the purpose of the holes in the brake pads. Okay, so for part A, you are asked to find the maximum deceleration F1 driver experiences, right? So you need to come to a stop in a straight line, rectilinear motion. What is the maximum deceleration that it can happen? Okay, like I mentioned, if you read carefully from paragraph 2, the data is actually given, being a data question. Just remember, read carefully, underline all the numbers, make sure you pick up certain key information. Okay, the speed from 185 km per hour, the braking distance is 80. Right, so assuming that the acceleration is constant, a rectilinear motion, v square equal u square plus 2as, I come to a stop, so v is 0. U square, make sure 185 km per hour, so make sure you convert to second, right? 60 times 60 plus 2a displacement, right, which is 80. So I find that the acceleration here is minus 16.5. So the deceleration is about 17 meter per second square. Okay, generally most of the answers were correct. A number of students tried to use the graph, the temperature graph, and the coefficient of friction, right? But there's no tire temperature given, right? So do take note whenever you read a graph, make sure you know what you're looking for, right? Conversion of units, right? km, meter per second, okay? So be careful of the units. Okay, B1, they ask you to find the maximum speed a F1 car can travel around the tightest corner. So this is a cornering, there's some circular motion involved. Para 7, I find that the acceleration, they are told that it can go up to 4G. Okay, so for circular motion, it's a circular corner. So I use a formula for centripetal acceleration, V square R. So my acceleration is 4G, 4 times 9.81, V square divided by the radius. So radius is given as 30. I can work out my speed as, maximum speed as 34 meter per second. So this, again, how do you know what formula we use? I think there's some idea of circular corner. Right, so and also you have to sieve out the number of centripetal acceleration told to you 4G in paragraph 7. Okay, a number of students were able to get the answer. Also have to be careful again. Tire temperature was not told, but do not randomly use the graph. There's no temperature given. Then 4G, the 4G is actually a centripetal acceleration, your AC value, right? So be careful when you go into centripetal force, the equations is FC. So be careful how you use the 4G, right? The value of 4G. Okay, part 2, they ask you to reference to 8.1 and 8.2. Okay, why the tires are heated before use. So this is a 3-mark question. So do take note that you have to reference to the figure given, right? Suggest and explain, right? So quite some rigor involved in your explanation, right? Okay, so why you need heating of the tire? This is to increase the maximum frictional force. And the temperature, if you look at the graph, the coefficient of friction increases according to figure 8.1, right? So this graph is useful, figure 8.1, right? Temperature gets increased. You're also told that the tire is softer, so there's a larger contact, which is also good, right? If there's a larger contact, means the frictional force will be increased. If the frictional force is increased, that is good because if you are going around a corner, that provides the FC, right? So that's why you can have a greater acceleration better cornering at high speed. So all in all, you are looking at increasing the maximum frictional force. Okay, be careful with that. You have to reference to the two figure in figure 8.1 and figure 8.2. Okay, generally this question was well answered, right? Of course, being both diagram, you have to reference to both diagrams. So careful. Just make sure you do not just explain one of them. Okay, large frictional force required to accelerate, decelerate, and corners at high speed. Okay, part C, they give you a section of the rear wing. There's actually a movement of air across the wing. So the wing has is curved in a certain way. The wing deflects the air when the car is moving. Okay, this question specifically want the change in momentum of the air, and why does this seems to make the car feel heavier? So the apparent weight will increase. So they ask you specifically for the change in momentum of the air, and why the weight seems to be increased. Okay, so since the question specifically asks for change in momentum, so there are a few concepts involved. So you probably need to think of Newton's second law, your force, change of momentum, how does it correlate to force? And then using Newton's third law, how come there is a upward and a downward force, and why the downward force will cause the increase in the weight of the car. So if you use a vector diagram, momentum is a vector. So I use a vector diagram here. I can find that the initial momentum, my change in momentum is P final minus P initial. Right, so my P final, because the air seems to have gone up, so this is my P final. My P initial goes this way, but because of the negative, so it swap the vectorial direction. So my change in momentum will go in this direction. Okay, so if my delta P is this way, so if I write my delta P, my change in momentum, so and we know by second law, delta P will correlate to force. So that means there is actually an upward force on the air by the wing. Right, so this is an upward force on the air by the wing. So by Newton's third law, there must be a downward force on the wing by the air. So this is actually the force that causes it to increase the weight of the car, right? Because there's actually a component of it that causes it to increase the weight of the car. So in summary, there's some idea of Newton's second law, which give me a change in momentum and which can be correlated to force. So by Newton's third law, there's actually a downward force, but there's a certain component of this downward force that goes in the vertical direction. That's why the weight of the car will be increased. Tougher question. So most students fail to, I mentioned the change in momentum of the air when the question already stated that you are expected to reference your answer to change in momentum. Okay, so many responses only focuses on the answers, forces acting on the air and the car. So there must be some link from the change in momentum to the force. Okay, part D, this diagram of the F1 car is actually a case of a question on moments. So I have a view that a car that is moving, the NR normal contact force for the front and the rear, NR and NF. Okay, the center of gravity, the distances are given as XR and XF. Okay, part 1, you are asked to take moment about CG to show this. So by vertical equilibrium of forces, the two upward forces must be equal to the weight. Okay, this car is in rotational equilibrium, so it does not topple. So you are asked to take moments about the CG, right? That means the clockwise moment must be equal to the anti-clockwise moment. So my clockwise moment is NR times XR, force times perpendicular distance, right? My anticlockwise moment will be NF times XF, anticlockwise. And of course, there's also a D times a H, anticlockwise moment. Okay, so based on the principle of moments, I get one equation. Okay, knowing part one, your equation for NF, I can sub into this equation. Then I factorize them. Okay, and then from there, I can get the answer for NR. Right, so the key here is actually taking moments about the center of gravity and knowing that there are three forces and make sure you know where are the perpendicular distances. Okay, so the good responses, of course, based on question instruction, you take moment about the CG, you should be able to get the answer. Okay, some of them forgot about the relationship between the vertical forces, NR plus NF equal W. And question already told you to take moment about CG. So please do not take moment about the front wheel or the rear wheels, right? Okay, part 2, you're asked to determine a similar expression for NF. So by vertical summation of forces, I get an expression. So NR is given as earlier. So I sub the expression for NR inside here. And then I factorize them. I factorize out. Then I do some cancellation, WXF minus WXF. So what I'm left is this expression for the normal contact force on the front wheel. Okay, part 3, you're asked to use expression in part 1 and part 2 to show that there's a weight transfer. So when the car is accelerating, there must be a weight transfer from the front to the back. So apparently the rear wheels will feel heavier. Okay, if you look at your expression in front, right? Then there will be a factor of DH over XF plus XR. So when there's a driving force D, then this factor cannot be ignored, right? So the normal contact force on the rear will be increased by so much. So when there's a driving force, the normal contact force on the front will be decreased by similarly an amount. Okay, so because of this, whenever the car is accelerating, there's a forward force, there's acceleration. The normal contact force will be transferred between the two front and the rear. So there will be a weight transfer of a certain amount from the front to the rear, all based on this fraction, this ratio. Okay, D is actually a driving force. So you have to take note from the expression mathematically given, right? So that D increases as the car accelerates, right? When there's a A, there's a F, and F, your driving force, is actually known as D in this case. Okay, part 1, calculate the maximum temperature increase. Okay, when you start to brake to rest, the count, you're asked to find the temperature increase, right? The average specific capacity is given, C. So this question is a bit on thermal physics. Okay, so what happens is the KE loss, half mv square, right? The half mv square must be equated to the gain in thermal energy, mc delta T. So it's integrated across the work energy power a Newtonian concept to thermal physics side. So the mass is given, the velocity, you need to convert to meter per second. Okay, because there are 4 brakes, so you do mc delta T, make sure you multiply by 4 because there are 4 brakes. Then from there, you can work out the change in temperature of about 180 degrees Celsius, right? The increase. Many candidates, of course, did not recognize how the change in KE, the work done by the frictional forces, right? And the temperature increase. So you need to establish that fact that the loss in KE will be equated to the gain in thermal energy by a concept of conservation of energy. Okay, with this, then you are asked to state assumption you have made in E part 1. Okay, so based on E part 1, if you look at what you've done, a concept of COE, loss in KE equal to gain in thermal energy. So we assume that all the thermal energy is in the brick disk. There is no heat transfer to other parts. So it's an ideal case where all the KE is lost, is converted to the thermal energy gain in the brick disk and no heat transfer to other parts. Okay, avoid vague responses. Do not just say energy is not lost to surrounding. Well, make sure you are clear, you are very specific about what type of loss is that, where is the energy loss. Suggest 2 reasons why the discs have very small holes. Okay, why they have so many small holes? This to allow heat dissipation. Better heat dissipation by increasing the surface area. You want to reduce the temperature of the brick pads, avoid overheating. Okay, of course, the other one is to reduce water trap, right? So that when it's raining, for example, it's dangerous. You want to avoid water trap in them, right? Because you have many holes, and then it allows the water to be dispersed away. And so the need to reduce the brick temperature was good. To prevent overheating was recognized. Okay, small holes, many students suggested that small holes increase the friction, make it more efficient, or rather the act as insulator at increased temperature, which was wrong. Okay, so this is the end of part 2, paper 2. I'll go on to paper 3, question 1. Okay, question 1, you have upthrust. It's actually a question of upthrust forces. Okay, you have an object, a sphere that is inside the water. Explain why the liquid exert an upthrust on the sphere. So this is actually a question on upthrust, the formation of upthrust. So how is a upthrust exerted? Okay, so we know the pressure increases with depth, pressure equal to rho GH. So because of this, there is a height difference between depth. So my pressure is also equal to force over area. So once I have a force, the upper force larger than the downward force, so there's a net upper force due to the pressure difference, which is due to the height difference. Okay, so it was well understood that the upthrust arise from a pressure difference, rho GH. Okay, the sphere was not in equilibrium. Many of them assume and incorrectly attributed the upthrust to different in density, density of liquid and density of the sphere, right? Okay, avoid doing this. Upthrust is due to a difference in pressure between the top and the bottom of the sphere. This is weaker, but because it does not have any explanation, right? Try to explain a bit more. Why the pressure difference exists or why it produces an upper force. Okay, part 2, you're asked to define the equation upthrust, rho Vg. So this is well known, but because this question asks you to explain your working, so make sure you show your working. Archimedes principle, upthrust is defined as the weight of the volume of water displaced. So we do mg, m times g, and m equal to rho v, density times volume. So volume times density times g. So that's how I get my rho vg, which is a well-known formula for upthrust, right? So by now you should know upthrust equal to rho vg, but just make sure you know what is the density given, right? Because in this question, you have density of liquid and density of solid. Okay, part B, you're expected to draw 2 graphs to show the weight. Draw a line, 2 lines on the same graph to show the weight and the upthrust. Okay, the weight of object is actually mass times g. So the mass is volume and density. So there's no dependence on height. So the upthrust similarly has no dependence on height. So therefore, if there are no dependence, it must be straight line, right? Straight horizontal line. Okay, then how do you know U and W, which one is higher or which one is lower? The W is lower, right? Because of the density given, right? The density of the sphere is less than the density of the liquid. So the upthrust, the horizontal line for upthrust must be higher than the horizontal line for weight. Okay, majority of the candidates realize that the weight is independent of depth, right? Because mg, right? But if you are aware that the upthrust is rho vg, then you realize that it does not depend on h, right? So rightfully, there should be two horizontal lines, right? With one line on top each other. Part C expected to show the downward force with the depth h, right? Both atmosphere and water pressure. So take note that there's actually atmospheric pressure involved. Okay, so pressure at the surface must be due to pressure of water plus whatever the atmospheric pressure on top. So this pressure of water is rho GH. So my force is pressure times area. So I'll get a pressure ATM A plus whatever here, right? The equation. So if I'm plotting F against H, I should get a y-intercept of area pressure ATM. Okay, and this is actually a positive gradient of A rho of liquid and G. So your graph should look like a positive line with a certain y-intercept and a slanting upwards. Okay, so for this question, do take note of your atmospheric pressure since I already told you. So make sure you have a pressure ATM in your equation. Okay, question 4. Question 4 talks about a wave and a superposition. Okay, state how a wave is formed. Okay, a wave is formed by the repeated interference of two progressive coherent waves, same type, same nature, same frequency, same wavelength, same speed. They should have about the same amplitude and they travel in opposite directions, right? So that they overlap, they interfere. Okay, part B is actually a tuning fork. So this is a case of one of the three cases that we have, open, two end open, two end closed, and one end open, one end closed in your lecture notes, right? Right, so this is a tuning fork that's on top, and until you hear a loud sound because of resonance. Okay, the loud sound indicates a stationary wave is formed. So I have a longitudinal stationary wave that is formed, right? So in this question, they tell you to explain, they ask you to explain how the representation illustrate a longitudinal sound wave. Okay, so there are two amplitude positions, one at the open end and one at the closed end. So the open end, I have a displacement antinode. The closed end, I have a displacement node, right? So the amplitude of vibration maximum near the rim, right, is a displacement antinode, right? And is zero at the water surface. So this guy is a displacement node, right? So this is how you describe the representation of the in figure 4.2 to illustrate a sound wave. Okay, this question is not asking you to define what is meant by a longitudinal wave, your parallel motion, right? No, of course, there are also some of them mentioning nodes and antinodes. Be careful when you mention nodes and antinodes, try to refer them to displacement. Nodes, displacement, antinodes, some of them went into pressure because we know by now pressure nodes, pressure antinodes mean a different thing from displacement nodes and displacement antinodes. Okay, but C, you need to draw the lowest frequency that is open at both ends, right? So this another case where it's open at both ends. Okay, a fundamental mode frequency, so I must have a displacement antinode, right? And a node displacement node at the middle, right? So this is a fundamental, the most basic stationary wave. Part D tells you that the frequency is 540, right? Now I increase the frequency, right? Until the next higher frequency. So if you are able to see a certain pattern, then it's faster, right? This is actually a 2N open, right? So fundamental frequency is 540 Hertz. I need to get the next higher frequency. So if you are not sure how to get the number, so just draw out the graph again. It's a displacement antinode at both ends, both open ends, and I have some displacement nodes. And this whole next higher frequency corresponds to a lambda. So based on your fundamental node, the length is half a lambda. So my frequency is V over lambda, which is given as 540. Okay, the next higher frequency is this one. So my L now becomes lambda. So my frequency is V over lambda, and lambda is L. So I will get 1080. Okay, so for those who are faster, actually you realize that I can just use 540 times 2 to get 1080 Hertz. And you round off accordingly to 1100 Hertz. Okay, most candidates answered correctly. Of course, some of them thought it's a lower frequency, 270, right? But they already told you the fundamental frequency is 540, right? And the next highest frequency. So the frequency has increased. So this is already told to you, right? Frequency has increased. So it must be higher than 540 Hertz. Okay, let's go on to question 6. Faraday's law of electromagnetic induction. EMF is directly proportional to the rate of change of magnetic flux linkage, right? Linkage of the conductor. So for part B, we have a coil that is placed in a uniform magnetic field, right? The coil has N, the coil has the area of cm square, 2.4 cm square. Okay, the magnetic field varies with time as such. So whenever you are given a graph, make sure you take note of what you can find from the gradient and what you can find from the area, if any, right, of the graph. Show that the change of magnetic flux density, rate of change, is given as 6 times 10 power minus 2, right? So this rate of change of magnetic flux density, right? So it's dB dt, right? dP or dt. So this is a B versus time graph. So what you need to find is find dB dt, right, at the start. So use a ruler, pivot at time equal to 1. Make sure you draw a straight line, pivoting at time equal to 1. Find the gradient of this graph. You should be able to get 6 times 10 to the power minus 2. Okay, because it's a show question, just take note that you have to show all your working, right? Including how you find your gradient. The gradient of the graph, pivoting, drawing at pivoting the line at 1.0 second. Okay, so be careful that you have to draw a long tangent, right? Points that are used should be as far as possible, right? Do not use 2 points to find your gradient triangle. That are the points that are too close together. Okay, part 2, find the EMF induced in the coil at 1.0 second. So you are expected to find the EMF. Okay, so in here we have to use Faraday's law. How to find the EMF from dB over dt, right? So according to Faraday's law, I have this formula, E equal to minus rate of change of magnetic flux linkage. So I have N, number of turns, 140, area, but area is 2.4 cm square. So make sure you do the units conversion accordingly. dB over dt is already found earlier on, 6.0 times 10 to the power minus 2. So you can work out the EMF as 2 times 10 to the power minus 3 volt. So this question is actually applying the use of Faraday's law, right? E equal minus rate of change of magnetic flux linkage and using the gradient of a B versus time graph. Part 3, now we need to plot, we need to sketch, right? How the EMF graph look like. So from a BT graph, I need to plot a sketch, a ET graph, EMF. So the relationship will be that of Faraday's law, right? Use Faraday's law to link B graph to a E graph. Okay, so your E graph, your EMF graph will come from dB over dt, proportional dB over dt, right? So what I can do now is, because you're asked to sketch, right? So you can plot a few points, of course, from time 0 to 1 second. So at the start, there's no EMF, right? There's no, yeah, so you draw a straight line. Okay, then the next point is probably critical, is somewhere at 4.4, 4 point here. So at 4.4 second, the gradient is 0. So you can see there's 0 gradient. So dB over dt is 0, which means your EMF must also be 0, right? So EMF is also 0 from here onwards. Okay, so this part you have to do some accurate plotting, right? So that you can get roughly the shape. Okay, but generally you also can see that the shape, the dB dt, the gradient decreases. So the EMF should also decrease from 1 to 4 plus second. Okay, so what you can do to be more accurate is to plot out a few points so that you can get the curve, right? Repeat what you've done in front, the NA dB dt, NA dB dt, you can, but of course now you need to work out the dB dt for the various field timing. Okay, work out a few set of EMF, plot the points, onto the E graph, and you can get a curve, downward curve. Okay, so for a graphical approach, just make sure you understand what's the use of the gradient, what's the use of the area. Okay, axis is important, the units on the axis. Can straight line, be careful when is gradient decreasing or not, increasing gradient or not. All right, so get a few critical points first. For example, T0 to 1 second and T at 4.4 second onwards. Right, then the rest, the in between one, you can plot a few points, right? Plot a few points to sketch a graph. Okay, question 9, yeah, the long question for 2020 is actually on electric and magnetic field. State what is meant by a field of force, a region or space when an object possessing a certain property experiences a force. Okay, this is a moving charge. This is a moving particle that is uncharged, and then a not moving charged particle. So a moving uncharged particle, the force is actually mg, right? Mg. If it's uncharged, I cannot have magnetic force, electric force. So for part 2, if it's stationary charged particle, I still can have mg, right? But I still can have QE because there's a charge. So I can have electric force, but I cannot have magnetic force because of BQV, right? So there's no velocity. Okay, so the comments based on this, some incorrectly suggested that a stationary charged particle experience a magnetic force, right? BQV, right? Magnetic force is BQV. If there's no V, then there's no magnetic force. Part B is on if you a charged parallel plate and you have a parabolic motion for the electrons that pass into the plates, right? The plates have a length of 12 cm. If U is constant, initial velocity is given. Okay, use of kinematics for part 1. You're asked to find the time for the electron to travel a horizontal distance. So this is on kinematics, right? Parabolic motion, right? So you just need to recall Sx equal to uxt. So I can work out T, horizontal displacement, divided by horizontal speed. Okay, parabolic motion for kinematics. Part 2, find the magnetic acceleration. Okay, so F equal to QE, the electric force is QE. E is equal to V over D, potential difference divided by distance apart. And this electric force causes a MA, right? So MA equal to QE. So from here, I can work out what is acceleration, right? Charge of an electron. If you forget about this value, you can plug it out from the data and formula page. Potential difference, distance apart, and the mass of electron, 9.11 times 10 power minus 31. So there's actually acceleration of so much. Okay, this is how various attempts by candidate equation of motions answers on horizontal velocity when clearly the acceleration is in the vertical direction. So this is wrong. Okay, now you are asked to determine whether the electron will collide with one of the metal plates or not. So you need to use the answer in part 1 and part 2, right? Check that whether the electrons will pass through the plate or not. Okay, if you consider the vertical motion, okay, the plates, so the electron comes in, the electron will deviate up. Okay, if you find your vertical displacement for this movement, ut plus half at square. So my initial uy is 0, right? Because it's moving inwards to the right horizontally. Half ay, this ay, vertical acceleration, this is the time. So if you plug in the formula, the numbers, you work out, realize that the displacement is about 1.13 cm. So I need to compare, okay, I'm moving in from the middle. So the maximum I can go is 1.2 cm, right? So since now this is less than 1.2 cm, that means the plate will pass through the region without hitting. So a comparison of the 1.2 cm against the 1.13 cm displacement, vertical displacement of the electron. Right, so this is a concept based on kinematics, right? Sy equal ut plus half at square, yeah, incorporated into electric field. Right? Okay, so you can calculate, like in this case, we found the Sy 1.13 cm, or alternatively, you can find the time it takes to travel vertically. Okay, just be careful that you need because it's midpoint, so you instead of 1.2, be careful, some of them actually use 2.4 cm, right? So yeah, launch at the midpoint, you should be comparing against 1.2 cm. Okay, part D goes into magnetic field. After you're done with the E field, there's a bit of B field, right? So remember the integration of topics, right? E field, B field, and G field, gravitational field, right? So the field, the direction of the field is into the page. Okay, this particle go in and turns in a circular motion. Part 1, they ask you to explain why the path is circular. Okay, so again, this is something got to do with what we have done in circular motion, right? It's circular because what you can talk about, the force is perpendicular, right? The centripetal force perpendicular does not change the speed. So the direction changes, but the speed, the velocity changes, but the speed, the magnitude does not change, right? So the PQV remains the same. The magnetic force provides the centripetal force, right? So that's why it goes in a circle. So some concept of scalar and vector, the speed does not change, the magnitude does not change, but because the force is perpendicular to the velocity, the direction changes. Then, okay, lack of detail was very common. Also have to understand that the magnetic force is perpendicular to the velocity, right? Find the mass in atomic mass unit of a particle. Okay, because it's going in a circle, the magnetic force provides the centripetal force. So always try to write a statement like this. The PQV, the magnetic force, provides the centripetal force. So you rearrange this, you'll get M equal to BQR over V. Magnetic flux density is given. The charge is electron charge. The radius you have to divide by 2 because what you are given is actually a diameter. Then you divide by the velocity, right? Once you have found the answer in kg, remember they want in terms of U, atomic mass unit. So 1 U is 1.66 times 10 to the power minus 27 kg. Remember to make sure you know how to convert kilogram to atomic mass unit, right? So work out, you'll get about 14 U. Okay, conversion was a issue, kilogram to atomic mass unit. M equal to use, but some of them actually forgot, they make a wrong substitution. Okay, singly charge, do not use 1. Instead, you use an electron charge. It's not a 1 coulomb, it's an electronic charge, 1.6 times 10 to the power minus 19 coulomb. Okay, part E, we have some changes now. The mass is a bit smaller. Q is still the same. So how does the mass affects the path? How does the mass affects the circular path? Okay, so formula that you should roughly know by now is this, right? R equal mv or bq. So your magnetic force provides the centripetal force, your bqv, mv square r. If you rearrange them, you'll get R equal to mv, which is momentum, divided by bq. So R is proportional to mass. So a smaller mass means the radius will be smaller. So you go into a smaller circle. You subscribe a circle of a smaller path. So smaller mass will have a circular path of smaller radius. Okay, this question asks you to suggest, right? So there's fair bit of explanation required, right? Smaller mass will give you a smaller radius because of the formula R equal to mv over bq. Part 2, now I change the charge, I double the charge, but the mass is still the same, and then you're asked to give a quantitative, right? Quantitative means numerical value, quantitative value, a number, a numerical value. So when a charge is double, right, the mass is the same. When the charge is double, when Q is double, the R will drop by half, right? So when Q is increased by 2 times, the R will drop by 2 times. So the R will be half, means the diameter will also be half. So you use a diameter divided by 2, you'll get 7.4, right? So you must write an answer of 7.4. Okay, take note the question asks for diameter, not radius. So make sure you also write the number for them, a quantitative value, right? A numerical value, a number for the diameter of the path. Okay, that's all for 2020. I've selected a few questions that are hopefully challenging.